So good morning, Alok. Are you
Good
comfortable?
morning, sir.
Can I start the session?
Yes, sir.
Okay.
At 2022, and since
Okay.
then I have been preparing for BRC interview through BRC written
Okay.
exam.
Okay. So tell me your favorite subjects.
Sir, strength of materials, structural analysis, RCC, fluid mechanics, and geotechnical engineering.
Okay. ठीक है. So at first, let's start with RCC.
Okay, sir.
Tell me what do you know about interaction curve?
Sir, interaction curve is used in column design.
Hmm.
Actually, in column, if load is not axial, if it is at some eccentricity, then bending
Okay.
moment also gets generated in the column. So to
Hmm.
get the permissible load, a column interaction diagram is used.
Okay. What are the x-axis and the y-axis of this interaction diagram?
Sir, x-axis is the moment and y-axis is the load.
Is it only the moment or some factors also with that? Do you get the value of moment on the x-axis?
No, sir. No, sir. Actually, sir, the interaction curve are of two types. Sir, one is in the dimensional form and another one is in the non-dimensional form. So, in dimensional form, it is a Pu upon FCK BD, whereas moment axis is Mu upon FCK BD square.
Okay.
No, sir. Mu
Uh,
upon FCK. Okay.
okay, fine. ठीक है. Do one thing. Do you have a piece of pen and paper? Paper
Yes,
and
sir.
pen? Yeah.
Yes,
So
sir.
draw one interaction curve. Show me.
Yes, sir.
Yes. So the curve cuts the y-axis at some point, right?
Yes, sir.
What is the significance of that point?
Sir, the significance of this point is that at this point only axial load is acting and moment is zero, which means that load is purely concentric. It does not have any eccentricity.
Okay, very good. Tell me the point of balance failure.
Okay, sir, the point of balance failure is a point at which
Show it on this
the
diagram. Show it on this
okay, sir,
diagram.
okay, sir.
Okay. So now what is the significance of this point?
Sir, the significance of this point is that the bending moment acting on the beam is such that
Hmm.
due to this bending moment, the
Hmm.
permissible strain in steel and
Hmm.
concrete reach
Hmm.
simultaneously. So it will be a balanced failure.
Okay. So in this case, what is the value of the neutral axis depth?
Neutral axis depth.
Hmm. Like just tell me whether it lies in the cross section or it lies far from the cross section. What can you tell?
Okay, sir. Sir, it lies in the cross section.
Okay. Good. So show me the regions of tension and the compression failure in this interaction chart.
Okay, sir.
Hmm. So now tell me what is the difference between this balance point and the point which you have shown ET? What is the difference between those two points?
Okay, sir. Sir, at the balance point, the strain in steel and concrete reaches simultaneously. Whereas if we increase further eccentricity, then moment acting on the beam will be much higher, and uh, it will be that the failure of column will be brittle.
So is it for uh, when it is brittle failure, it will be in the compression failure. So you have marked
Yes,
this at the indicated in the boundary of the tension layer. So what is that? Are you sure about this? Whatever you are telling. Take your time. Take your time. Think.
yes, sir. So slight modification. Compression control region
Hmm.
is up till balance point, whereas below that it will be tension control region.
Okay. Okay. Fine. Okay. So now let's move to the next subject. Uh, do you know the working principle of reciprocating pump?
No, sir.
Okay. Centrifugal pump.
No, sir. Actually, sir, I have left hydraulic machines.
Okay. No problem. Okay. So I will ask you something about the fluid mechanics only. Okay.
Okay, sir.
Uh, what is the difference between streamline, straight, and path line?
Sir, streamline, streak line, and path line.
Yes.
Yes, sir. Sir, streamline is the path followed by the particle. A tangent at which tangent at any point gives the direction of velocity of that particle. Whereas, sir, path line
Which
is
kind of
the
velocity is given? Is it the tangential velocity, radial velocity? Like the particle moving will be moving on a curved
yes,
path.
sir.
Okay.
Yes, sir. Yes, sir.
So
Sir,
it
it
will be
represents
having
the
two components of the velocity.
yes, sir.
Huh.
Tangential velocities.
Okay.
And sir, coming to the path line, sir, it tells the time. It has a time history, and it tells the uh, sir, just a minute, sir.
Okay. Take it.
Sir, path line is the actual path followed by the particle over a period of time. And
Okay.
streak line is the end points of the path line of the different fluid particles which have passed through a given point.
Um, I did not get it properly.
Okay, sir. Sir,
Can
suppose
you
there is
explain
a
it
sir,
more properly? Yeah.
suppose there is a nozzle through which fluid particles are coming, and
Hmm.
suppose we take a time t and a time t1 and a time t2. So different fluid
Yes.
particles will be passing through that point over a period of time. So the
Hmm.
sir end point of the path line of these
Hmm.
fluid particles, which when connected at a time, is will be the
Hmm.
straight line.
Okay. Fine. So how does kinematic viscosity of liquids differ with pressure?
The liquids differ with pressure.
Yes.
Sir, it remains constant with the pressure.
Kinematic viscosity for liquids.
Yes, sir. Kinetic viscosity will remain constant with the variation in pressure.
Okay. And with temperature?
Sir, with temperature also it will remain constant.
Okay, good. Tell me the working, like how do you solve Hardy-Cross method? If you are given a network to solve through Hardy-Cross method, so at first tell
Yes,
me
sir.
why is the Hardy-Cross method used? What is the basic principle involved in that? How do you solve a network through Hardy-Cross method?
Sir, a Hardy cross method is used to solve the. Suppose we have a junction of several number of pipes, and we have to solve whether how much
Okay.
discharge is going through each pipe. Then we use Hardy cross method. And the
Hmm.
basic principle in the Hardy cross method is that the total fluid entering at a junction should be equal to the total fluid leaving the junction. And in this method we consider a loop, and according to the sign convention, either we take clockwise positive or anti-clockwise positive. So, and the formula for the correction in head loss is,
so head loss in the loop remains constant.
summation of head loss in the loop is constant.
Constant or
Algebraic
zero?
summation. Yes, sir. Algebraic summation of, sir, zero.
Is it constant or zero?
Sir, algebraic summation is zero.
Okay. So show me the formula which you have written.
Sir, that bottom.
So what are R and N here? R and N.
Okay, sir. N is a factor on which the discharge value depends, and sir, R. Sir,
No,
actually, sir, in
I did
hardy
not
cross
get
method,
it properly. What is this R and N? What is that factor?
sir, R. Sir, suppose if the head loss varies, head loss normally varies to some power of the Q, and that, sir, suppose normally in a friction loss, it is FLQ square upon 12.1 d the power 5. So, sir, here Q is equal to 2. So, in a way, it represents that in what ratio the head loss depends on the Q, or on
Okay,
what
fine.
factor of Q
Fine. Fine.
H depends.
Okay. Okay, suppose there are different pipes meeting at a junction. Okay.
Yes, sir.
So at the point of junction, what is the velocity head pressure value? How do you estimate
What
the
is it?
velocity head at the junction point? Kinetic head at the junction point of the meeting of different pipes. Let us take an example to clarify it more. There are three reservoirs. Okay. Water from
Yes,
one pipeline is coming. Suppose from reservoir A, pipeline is coming. So water from pipeline
yes,
A is going to B and C. Okay. Two different pipes.
okay, sir.
Okay. So there
Yes,
are
sir.
three pipes. One from A to center, then center to B reservoir, and then center to C
Yes, sir.
reservoir. So at the
Yes,
point
sir.
of junction of those points, what is the value of the kinetic head? How will you estimate that?
Sir, it will be the summation of the kinetic head of the individual pipes.
Are you sure?
Sir, sir, just a minute, sir.
Take it.
Sir, for individual pipes, sir, suppose water is coming from reservoir A to reservoir to center O. So, sir, in that case, sir, the total head at A will be higher than total head at center. That's why
Agree.
that is the reason of the flow. Yes, sir.
Okay,
So,
agree.
to find the kinetic head of pipe OA, sir, we will apply the Bernoulli equation between A and O, and according to that, we will find the velocity head of pipe AO, and this will give us the kinetic head. We will find the velocity of the pipe, and that will give the kinetic head. Sir, similarly for pipe OB and OC, sir, we will individually apply Bernoulli equation.
So you're telling that you will be getting three different velocity heads at a junction point. Think. Okay, okay, no problem. Tell me, have you heard the term funicular polygon?
Sir, I have heard, but didn't complete it. Remember, sir.
Okay. Linear arches?
Yes, sir.
What are that linear arches?
Sir, linear arches are that arches in which the bending moment diagram, shape of the arch are proportional to each other.
Show me with an example.
Okay, sir. Sir, the load acting on the then the BMD found that should be proportional to the shape of the arch. So, is it visible?
Okay. ठीक है. Now take an example of a 2-hinge parabolic arch. Okay.
Yes, sir.
Take an example of 2-hinge parabolic arch. It is subjected to UDL throughout the
Yes,
arch.
sir. Yes,
How
sir.
will you estimate the value of radial shear at any section X from the support?
Okay, sir. Sir, to calculate the radial shear, we will cut a section at which it is required,
Cut and show.
and
Cut and
then
show.
okay, sir. Sir, that RS part is the radial shear.
Okay. And so how will you estimate the value?
Sir, by using the equilibrium equation on the left hand side of the arch, that is summation force equilibrium equation. Summation
Okay.
of x is equal to 0 and
What is the shear and radial shear here?
sir, shear and radial shear.
Are these two different or same?
Sir, for any plane structure, sir, which has a constant curvature or whose sir, radius of curvature is infinity, we use the term shear. But in case of arches, as the radius is changing at every point, so we use certain radial shear.
Okay.
This is what I can
So
guess, sir.
okay. Okay. So can you tell me the value if the loading is W, span length is L?
Yes, sir.
Okay.
Yes, sir.
And what else do you need? So
Sir,
loading and span
the
length are
section from
given.
the left point, from the left hinge.
Take it as a L by 4.
Okay, sir.
So have you started solving the indeterminate structure?
Sir, sir, actually, this is a standard case. So, sir, the value of horizontal reaction is, sir, I remember.
Okay. What is that value?
Sir, WL square upon AH.
Okay. Fine. Proceed. Tell me the value of radial shear force at L by 4 from the support.
Okay, sir.
Did you get some value?
No, sir. Still solving, sir.
Okay, fine. Show me the step till you have that solved. Hmm, okay. Okay, fine. Okay, one last question from RCC segment once again. Uh, just show me the area of tension reinforcement in case of a retaining wall for the stem part. Reinforcement detailing of stem part of a retaining wall.
Okay, sir.
Take a general case where the soil is backfill is on the left right hand side. Okay, sure.
Okay.
Okay, fine. Okay. So thank you, Alok. Your interview is over now. Okay.
Okay.
So I could see, yeah. Just let me conclude by giving you proper feedback. Okay. So at first, what I could see is you are conceptually very good. Okay. At least
Yes.
you know about the points very well. At first, when I started with the interaction curve, many students just know what is interaction curve, but do not know about the points in details. So you try to
Yes.
explain them very well. But again, at the same time, when it comes to the balance failure and the cutting on the XSS point, so just go
Yes.
quickly through it. I know you know it well, but you are slightly
Yes.
confused here. It shows that you are slightly confused at that point. Okay, just
Okay.
check it once. Okay, then
Yes.
in case of pathline, streamline, you explain properly. Pathline and streak line, I also feel like you need to study somewhat more on that part. Okay, so
Okay.
just to go revise that properly as well.
Okay,
Okay,
sir.
the exact difference between the pathline and streak line.
Okay, sir.
Okay, because this is a very common question that is asked
Okay,
during the
sir.
interview. Okay,
Okay, sir.
the next thing is once you are deriving the Hardy-Cross method. So if you are showing the formula,
Yes, sir.
okay, then you must know what is R and N, which
Okay.
indicates that you have, like as I know, which pertains to me, is you only know the formula. You
Yes.
do not know the derivation of that formula. Okay, so
Yes, sir.
once you are
Yes.
able to derive that formula, you will be able to properly tell what is the value of N and R. Okay, so where
Yes,
does
sir.
this R
Okay.
and N terms comes from? Okay, then you will be able to explain that properly. In term N is six terms. Once I show, like once you write the formula from the starting, very starting deriving, so you will get to know what is this R and N term.
Okay.
Okay, then one very common question, like when two or three pipes meet at a junction point and then the flow is going from one reservoir to another reservoir. So it is one of the common assumptions that you must know. Like you already have used that assumption in solving your numericals as well, but you are not able to recall that kinetic head value at the junction is assumed to be zero.
Yes, sir.
Okay,
Sir,
so
that
at the
one, sir, I
junction
was
point,
getting confused, sir. Yes, sir. हम तो
हाँ,
P ले लेते थे और
yes,
फिर
yes,
लॉन्ग टेस्ट
yes.
कंसीडर ही नहीं करते थे, सर.
Yeah, yes, I know, I know. You should you don't feel confused in that. Okay,
Okay, sir.
I was just asking to. I was just trying to tell you that you should be able to started to solve that. Okay, but
Okay, sir.
just
Okay, sir.
apply your quick common sense because you know that formula, you know how that, but
Yes, sir.
you are not
Yes, sir.
able to tell at this point of time. Okay, so
Yes, sir.
at that point, the kinetic head is assumed to be zero. Okay,
Yes, sir.
if you do not assume that, you will not be able to solve the problems of those pipe
Okay,
networks.
sir. Okay,
Okay.
sir. Because, sir, we
Uh,
actually don't know the value of Q. So a kinetic
hmm,
hit can't be found. Yes, sir.
yes, yes. Now, linear arch and funicular polygon. These two are similar kind of things. So just go and
Okay.
quickly revise once again. Okay. So both
Okay,
of those are interconnected. Okay. Both of these are almost similar. So just see what is the exact definition of funicular polygon. You don't know about funicular polygon, but you know about linear arch. It is not possible at all. Okay. Both
Yes.
of those are the same, similar things. Okay. And the radial shear force, you started to, you must remember, if in case of 2-hinge or 3-hinge parabolic arch, which is subjected to U-dual throughout the length of the span, the value of bending moment as well as radial shear force is 0 at every point of time. Okay.
Sir,
So there was
because
no
yes,
point
sir,
of
yes, sir.
solving each and everything here. Just apply
Okay,
quick because the try to force you to solve it. Okay. But you should know
okay,
this concepts.
okay,
Na? I know
okay, sir.
once you start solving, you will come to the conclusion. But you are
Yes,
coming
sir.
to the conclusion at the last when you have checked all the patients of your interview panel members.
Yes, sir.
Okay.
Yes, sir.
So yeah, take care on these points. You are doing at least 3-4 points. I felt key where you felt a little bit stuck and you need a further improvement. Interview day.
Okay, sir. Sir, 15th of May.
Okay. So okay. So you have a lesser time. So just in
Yes, sir.
2 or 3 days, you quickly revise through once again the theory part of those portion, the
Okay, sir.
derivations, do not go by the numerical portion now, just the concepts and revise the concepts of it.
Yes,
So,
sir.
is that
Yes,
fine?
sir. Yes, sir.
Any
Yes, sir.
questions?
Uh, no, sir.
Okay, fine.
No, sir.
ठीक है, thank you, Alok. Your interview is over. You can leave now.
Thank you, sir. Thank you, sir.
सर 1 सेकंड सर रिव्यू ले लीजिए।